Hi, my name is Michael Kerr, and this is my data analytics capstone project. It's a case study on Cyclistic, the fictional bike share company. Before we begin, a little bit about myself. I'm a United States Marine Corps veteran who worked for 4 years as a data analyst in the Marines, working specifically with the maintenance management of equipment. Here are my links, specifically my LinkedIn, my email, and my portfolio, so you can take a look at my other projects. Now let's go over some quick background information about the project. Cyclistic is a fictional bike share company whose data is pulled from the real bike share company, Divvy Bikes. The data used for this case study is public data, so it does not contain any PII or any demographical information such as age, gender, etc. I will be taking on the role as a data analyst working on the marketing analyst team at Cyclistic. The goal of Cyclistic is to convert casual riders into members, annual members. A little bit about our fictional bike share company, Cyclistic. It's located in Chicago, just like the real company it's based off of, Divvy Bikes. Cyclistic has more than 5,800 bicycles and over 600 docking stations, and there was over 5 million trips this year. They offer a variety of bikes, such as reclining bikes, cargo bikes, and hand tricycles. Here are the objectives for this project. Firstly, we're going to find the differences between casual riders and annual members. Secondly, we're going to identify why casual riders would buy a membership. The reason these are the goals for the project is because if you recall, the goal of Cyclistic is to convert casual riders into annual members. Now let's get into the visualizations. Here's our first visualization, a pie chart showcasing the number of trips throughout the year. As you can see, there was over 5 million trips this year, 64% of which was conducted by annual members and 36% of which were conducted by casual riders. The blue will represent the annual members, and the orange will represent the casual riders. These color codes will remain consistent throughout the presentation. Our first major difference between annual members and casual riders that is apparent is that the annual members are taking far more trips than the casual riders. Now here is a bar graph depicting the total number of rides throughout the year by month. Both members and casual riders see a rise in the warmer summer months and a decline in the winter months. The main difference between members and casual riders shown here is that the winter decline is much more drastic for casual riders. Here we see a bar graph visualizing the total number of rides that occurred on each day of the week over the past year. Some observations to note is that the casual riders take less rides during the middle of the week, but take much more rides during the weekend. For members, the inverse is true. Most of the members' rides occur in the middle of the week. This could imply that members ride for commuting purposes, whereas casual riders ride for leisure purposes on the weekends. This pie chart shows us that the average ride length for casual riders is about 26 minutes long, as opposed to the average ride length of members, which is about 13 minutes long. A key difference to spot here is that casual riders, on average, take longer rides than members. Here we have a bar graph showing us the average ride length in each month over the past year. Casual riders see a spike in summer, particularly August. Members, on the other hand, have a fairly consistent average trip length throughout the year. Now let's take a look at the average trip length for each day of the week over the past year. Casual riders take longer rides on average during the weekend. The average trip length of annual members remain fairly consistent throughout the whole week though. Our final visualization shows which type of bike the riders prefer. The annual members have had slightly more rides with the classic bike than they have had with the electric bike. Casual members have had more of their rides on the electric bike. A very small portion of casual riders used the docked bike this past year, whereas 0 members used a docked bike this past year. Now I'm going to go over the process and the steps I've used to achieve these results. First, I downloaded and properly named, organized, and stored the files as Excel spreadsheets. There was 12 spreadsheets, one for each month. Then I created new columns to determine the ride length and the day of week the ride was taken. To determine the ride length, I used a subtraction formula. There was a column for the time the ride had started, and there was a column for the time the ride has ended. So my subtraction formula was simply subtracting the end time from the start time. And then I used the function equals weekday to determine the day of week that the ride was taken. And you can assign the numbers to the day of week. So 1 for Sunday, 2 for Monday, 3 for Tuesday, and so on and so forth. And then I ensured that all data was formatted properly. For example, the ride length must be formatted as HHMMSS, the time format, and then other like quantities would be in general. Once I finished adding those 2 new columns to all 12 of the spreadsheets, then I created a pivot table for each month to summarize all important information within that month, such as the average ride length for members and casual riders, the total number of rides for members and casual riders, the average ride length for each day of the week, and the count of total rides for each weekday. I also created another pivot table specifically for identifying data pertaining to the types of bikes used by members and casual riders. Once I created the pivot tables for each month, I then merged all of the pivot tables into a single spreadsheet for a full year view of the data. Here are the steps I've taken to achieve that. First, I created a new blank empty Excel file. Then I selected the Get Data option in Excel, and then I selected the From Folder option. Then I selected Combine and Load, and then I selected the sheets used for the first pivot table of each month. Now, if you recall, we created 2 pivot tables for each month. The first pivot table focused on multiple things, such as ride length, the total count of rides that were taken, and the weekday the ride had occurred. We're going to be only selecting that pivot table. The second pivot table that we created for each month, the one focusing on specifically bike type, we're not dealing with that right now. We're going to go back to it later, but right now we're only focusing on the first pivot tables we created. So once we do that, we're going to have a full year view of the data, and we're going to create a copy of that sheet. This is good practice because if we make a mistake later on, or if for any reason we need to go back, we'll have the original unedited sheet so we can go back and retrace our steps. So it's always good to make a copy of the sheet and then work on the copied sheet so you have that copy you can go back to. And then once I did that, on the new sheet, I cleaned and organized and simplified the data by deleting unnecessary rows such as blanks and repeats. Once I finished cleaning the data, I then created 2 extra copies of the cleaned data. In one copy, I deleted all the data pertaining to ride length so I can focus solely on the number of rides. For the other copy, I did the opposite so I can focus solely on the average ride length. At this point in time, I had 2 extra copies of the cleaned data. One that just has the number of rides and the other copy that just has the ride length. Throughout this process, I focused on more technical things as well, such as ensuring that all the data is formatted consistently and correctly. I then went back and merged all the pivot tables for bike types into a full year view using the same methods I did for the number of rides and the average ride length. I then cleaned and analyzed the bike type data into a more simplified view, and then once the data has been fully cleaned and analyzed, I created visualizations using Excel. After taking a look at all those visualizations, here are some conclusions that we can draw from the data. Firstly, casual riders appear to prefer the electric bike. Also, casual riders mostly ride during the summer months like June, July, and August, and the weekends, particularly Saturday and Sunday. Annual members tend to ride more during the middle of the week. Casual riders take longer rides, with ride length spiking during summer months and weekends, which implies that casual riders tend to ride for leisure. Members have an overall consistent average ride time across the week and the year, which implies that the members are routine commuters. It is likely that the casual riders ride for leisure and enjoyment as opposed to members who most likely use the bikes for commuting purposes. Here are some important notes to consider before we move on to the recommendations for the stakeholders. The data provided for this case study has limits, and therefore we should not make decisions based solely on this data. This analysis can be used as a factor, but there are other elements to consider that is missing from the data, such as demographical data like age and gender, the quantity of local users and visiting users, the income of the riders, and how many of the trips were from the same rider. Implementing a user ID into the data can help acquire this information. Now here are some recommendations that we've made based on conclusions we've drawn from the data. Firstly, surveys can be an effective way to obtain helpful data that is missing from the dataset, which can lead to even more insights. Next, it might be wise to offer benefits targeted at casual riders, such as discounted membership rates for new members during summer months and/or weekends. We could begin advertising these benefits during early spring or late winter to promote before the peak season. During advertisement, it could be wise to highlight the fact that most casual riders would save money with a membership plan. And lastly, here are the sources. The first source is the link to the data itself. That is DiviBike's actual real data from the real company. And then below it is the link to the license that basically says that the data is public and free and available for anyone to use. Thank you very much for your time. Thank you very much for watching this. And feel free to reach out to me if you have any questions or leave it in the comments. I'm open to all kinds of feedback. Yeah, thank you and have a wonderful day.